Okay. So I think some of you are still at question 2.6. Okay. Right, topic 6, part 2 notes. Okay, yeah, I checked yesterday. I think wrong. I will choose. Okay. You write down the correct one. Later I take photo of yours. But you wait for me first. Yeah. I thought, sure. You should say sorry. I never bring the notes. Thank you for airdropping me. Sure. Huh? Do the assignment also won't do 1 hour. What? You again. Thank you. Welcome. Able to copy over. Notes. Where's your assignment? You both also never bring there. What you come to class for? Also don't have. Then why are you in school? Both don't have. Huh? Okay. Go to question 2.5. I'm serious. I'm serious. Yeah. Your assignment never do, your notes never bring, then you go also do. Okay? Try to, so when you are at 2.5, you are there. Now you try to form using Pythagoras theorem. Form using Pythagoras theorem. Why are you, no, Joshua, you don't need your iPad. Just take your paper, pen, paper. Okay? Yeah. Using Pythagoras theorem. Okay? Pythagoras equation involving y and x. Okay, so what do I mean? Remember that connector of change, you will need three derivatives. So they are asking you how fast is the boat moving, right? That means they're asking you about this direction of movement. Let's say I call this variable x. Okay. So this question is difficult because I need to define my own variables. X, this is x dt. Let me call this y. Then this is dy dt. Okay, so what they're telling you is that dy dt is negative 0.75. The rope is shortening 0.75 meter per second. Okay? Can? Yeah. So now, children, you all see I got dy dt. I'm supposed to find dx dt. What is the last one? The last one I will need is dy dx, which means I will need y in terms of x. How do I find y in terms of x? Okay, think about Pythagoras theorem. If you look at this, y square, y equals to the square root of 3 squared plus x squared. That will help you to find your dy dx. Okay? Hey, do your notes. Do your. What's the reason why you never bring your notes? What's the reason why you never bring your notes? Are you not interested in the lesson? Not interested in the lesson, you don't want to stay here. You never bring, so you are not prepared for lesson or how to even take you seriously. You not take you seriously or why do you bring? Okay, so far okay. Are you all done? Okay, so since you are so the answer is actually negative 0.808. Some of you got 0.808, but you must take note because the dy dt is negative. So far, you must take note that dy dt is negative. So after you have y in terms of x, let's write it as 9 plus x squared to the power of half. What is dy dx? Dy dx is just half. So I differentiate the outside. Okay, differentiate the outside. Power go in front, power drop by 1. 2x. Cancel, cancel. Okay, this is the dy dx. Huh? Speed, okay, we are not talking about speed here. Oh, wait. Oh, okay, so we are talking about the distance, right? We are talking about the distance. Okay, so dx dt itself is negative. But when I write out the statement, I will say it's moving towards the dot at 0.808 meter per second. So, uh, it cannot be negative, but it can be. So if you're talking about velocity, it can be. So, Baba, you see, okay, this is what I find in mathematics equation. This is my right statement. Okay, so after you're done, you write out, negative, then negative 0.808, you need to write this out. Okay? To write velocity, all this, no need, no need. But you do need to interpret your answer. Okay, guys? So even though you got the numbers correct, let's make sure that you get the signs correct as well. Yeah. Okay. Okay. So let me say again. Let's look at the question. Okay. Now, if I want this entire thing, right? We remember that in our question, we want 3 derivatives. Okay, we want 3 derivatives. First one, how fast is the boat moving? So we know that when they're asking this, they're asking about somewhere along this dimension. I'm going to call it x. I'm going to call it x. Okay, I'm going to call this x. Okay. This about y. This is the rope. The rope is here. Okay, so this is the rope. Then, so let's call this y. And this is referring to dy dt. Dy dt is negative 0.75. Okay, can I? What does the question want? The question wants dx dt. The question wants dx dt. Okay, so now I have these two. Remember, one is given, one is hidden. Who's the hidden one? One is your price. This is my price. This is given. Who is hidden? Hidden is dy dx. So if I want dy dx, that means I need y in terms of x. Correct? How do I find y in terms of x? So, let's just divide. No, cannot. So that's why I need an equation connecting the variables. Under page 5 of the notes, you see there are some strategies like Pythagoras theorem, similar triangles, or right angle triangle. Over here, you'll notice that x, y, they form a right angle triangle. And this is theta. By Pythagoras theorem, y is the square root of 3 squared plus x squared. Okay, so far. Then what does it mean? Can I say that it can look like this? Yes, then I can find my dy dx. So after I find my dy dx, right, I sub in, for example, sub x equals to 7.5. Clear? Can I? So sub equals to 7.5, then dy, so the question one is, right? I form the equation first. Dy dt is dy over dx times dx over dt. Then dy dt divided by dy dx is the same as dx. Okay, this is the price. This is the hidden. This is the given. Okay. View 2.6. Okay, so 2.6. The key player in 2.6 is the triangles. Uh, First, having a looking at the. So, can anyone tell me, for example, okay, would you like to tell me which derivative does it represent? Very good. Also, you can see, Hayden can see that this is volume. Okay, so the that's right. The size here is E. So if this is the given and one is the price, what's the heat? Or you put E over. So K will look at this. That means she knows that we need V in terms of H. So on an innocent and humble journey, I go on. I find that volume is 1/3 pi base area times height. I didn't actually realize that, cannot lay terms. Huh? It's a square cone. Very good. I'm testing you. Okay, so 1/3 base area times height. Okay, so then I look at, right? This is not right, right? How can I have an X there? So what do I need to do? You all look at back again at this page, right? Many involving two triangles. So can I just tell to you that when you look at this triangle, look at this triangle. Okay, you all don't need to prove, Don't need to prove. Look at this triangle. Look at this triangle. Isn't this beautiful? Just like you. Okay. So this is H. This is 30. This is X. This is 80. Similar? X over 80 is H over 30. You should be able to get that X is 3 over 5 of H. Okay? So Archie, Kate, I think this will help to win your equation. Before you start, Archie and Kate, I would like you to make sure that you have this as your volume. You sub this as X, sub X inside here. Okay? How are you doing? Playing the thing. Are you writing? Take anything? You go and sit down. You go and sit down. It's okay. I don't want to bother about you. Go and sit down. You want to sleep, it's okay. Go and sit down. Go and sit down. It's okay. You want to sleep, you sleep. You tired, you sleep. Oh, there's the fish. After you have volume, you can do dV. Okay. dV dH square. After that, the water, then after that, you start H to be 10. So then I think HDT, if I'm wrong, it should be 5/36. Yeah, 5/36. Okay, huh? It should be 5/36. Make sure you show the full working, okay? Make sure you show show how you get them. You need to show. Okay, guys, you must remember collected rate of each question. You need to show so if I'll this is key criteria. For example, this you need to write this. So you can this collected must write. This is a must write. Can you all pay attention to what you need now? If all goes well, your dV will be 9/25 h square, and you can substitute h as 10. That will get you this, and dV dt is 5. Yeah, 5/36, perfect. So from here, you can substitute h to be 10. Why is h is 10? Because the crest is 10. Yes. Zero. It goes to 0.
It goes to 0.
Huh? Okay.
9,511 You got, I got. Aww.
Huh? As time goes with it, as the number gets large, e power negative x goes this way. So it goes towards 0. Strictly speaking, it is not 0, but there's only a certain number of decimal places the calculator can give you. So it can be a very small number, like 1 times 10 to the power negative 25.
So 10.
No, it will approach 0,
Oh,
but
so
it will never be 0. No, as in, don't believe what you see. Because okay, say hey, what's going on? Why everything is let's say if you say this is 0, can I learn both sides? Correct? You learn both sides, you will know why it fails. Okay. Okay, so I just wait a while more for all of you to finish your part 2.6. After that, you can start on part 3. Hey, what's this? Cosine power half.
Yeah.
Square root. How is this supposed to be? I'm not so sure. Where do they go? It may not know.
In the side over
Tangent.
twice.
Yeah, correct. Oh, okay, okay. So now I'll start on part 3. I think everyone is very comfortable. All of you are running off. Please be. So I need to tell you higher order derivative. Are able to do the question? Can you just make sure you do the SLS? Can? Now the SLS got some useful nuggets of wisdom inside. So the either F prime or Y prime or Y, yes. How to obtain derivative? Basically, we differentiate a second time. Okay, so far? Can I? We differentiate a second time. We can write it as, okay, dny dxn, or here, usually, can you all just look here? Can you all just look here? Okay, I want you all to, I know that you all know how to do, but I want you to say it properly. d2y dx squared. No. d2y dx d3y dx cubed. Okay, so say it properly to us next time. Don't tell your friend d3y dx3, d2y dx cubed. No, d2y on top is 2, below is square. Toilet, is it? Oh, sorry. Go. Are you going? It looks like you're excited to go and watch Eden. Okay. Who else is in COGZ? You also. Okay. Is it open? Not open. Man. Okay, give me a second. So, where's your phone? You are dismissed at 11. He's dismissed at 11. Okay. Then, you're trying to spook me, okay. How come you're 110 and 111? Is it he more time? It's a SL. It's a school leader. SL. Okay. Well, you know a lot about him, huh? Okay. So d2y dx squared is cube. You can also call it y prime, y double prime. Okay? But note, okay, when you start to differentiate, if I'm differentiating the first time, I call this one stroke, 2 strokes, second derivative, 3 strokes. If you're differentiating fourth time, can you put a bracket? Make sure you put a bracket. Don't confuse it with power. Okay, put a bracket. Don't confuse this with power. Differentiate for the n time. Okay, so you can see you can read it as f double prime a. Okay, what does the stroke stand for? It stands for Sean. It stands for prime. Can prime. So if this is say y, let's say if this is fx, what is f prime? 5x4. What is f double prime? 20x cubed. What is f triple prime? 60x squared. So you can look at this, it's so beautiful, right? It's just a cumulative effect. 120x. F fifth power 120. F6. You can see as I keep differentiating, all things will just go to 0 for polynomials. Okay? Can only for polynomials. Oh my days, you are so fast. You do so fast. Should I give you a star? Okay. I don't have star. Can I go through 3.3? Okay, so so if I were you, I would just do everything. I'll find y, dy, dx. So first, it should be equals. I'm going to write it as this manner. Sadhana, I write it like that. That's here time times -1, which is the same as 2, which is the same as 2. Okay. 1, 2, 3. Okay, so we're going to find Now I check my left hand side. My left hand side. Your right hand side. Eh? Does it not tally? Eh, no, I did wrongly. Sorry. You can see the left and the right are equal. Should. Okay? Okay. What are you doing? You are doing electrochem. Huh? Where's your notes? Ew. 5 days ago. Hello. Bring your father for a walk.
What the hell?
From PE. PE. Because of trees? Oh, it's the music. Music is on Monday. Yeah, when you write, you need to write the left interval minus 0.01. The right interval is plus 0.01. It cannot be it must be a small neighborhood. Are you doing the first derivative test?
Yeah.
Okay, you need to do a small neighborhood. You need to do a small neighborhood. You cannot do too big. If you do too big, your interval may become a next the stand 0.01. Always 0.1. Okay, 0.1 is fine. 0.1. Okay, let more as possible. Okay. Okay. Practice. Maybe you don't start for first. Wait for weekend. First, you wait for me. Oh, okay, good. Yen and Kang Yu. If you are done, can you do your practice set first? Wait for me, can? Yeah. I don't be the practice set. Maybe you wait for me first, can? I don't know. Draw a table. Draw a 3x4. 3x4 table. 3x4. Don't wait. I teach you all now, you're confused. Hey, we don't study chemistry. This over here. You see this one? This first topic. The first part. Topic 5. Can you just use this one? You just use this instead of using the mic. This over. This one. Hey, 英语 speak English. Who used to converse in Chinese with Dora? Dora? Oh, Dora Chinese very good. Are you a little fruit snack? Then what about you? Oh, your soulmate. Who's little fruit snack? I think it's Xing Yu. He just call himself a little fruit. Okay. For me. Okay, so let's say I go to 3.1. I want to find the 2y dx cube. So you can see it's really quite easy. You just need to differentiate it one more time. You need to differentiate it one more. So okay, can see now? Y equals, so dy dx, y is equals to 2x plus 3. What is the 2y dx cube? Dx square, sorry, 2. What is the 3y dx cube? 0. Easy, huh? So what is the idea? If it's of degree m, m must be 0 if the correct. It basically m must be greater than m. Like you can see here, if my degree is 5, and as long as I differentiate more than 5 times, I will get 0. Okay? Clear? So if m is greater than n. Okay, like example, here, you can just write this down. Okay, you can just write this straight away. Okay? Can I? So I think question 3.1 are done. 4.2, number typical O-level question. Okay. Now if y is equals to ax cube plus bx, dy dx is negative 4.25. Dy dx here, math. Okay. So this is equals to this is when x equals to 0.5. X is 0.5. What about the 2y dx square? This is also 6ax. Okay, is equals to 3. So here, this is y square equals to 3, x equals to, so a 0.5 is 3, a equals to 1. So here you sub x to be 0.5, a to be 1, dy dx is negative 4.25. What do you get? 3a 0.5 square plus b equals to negative 4.25. Your b should be, what is 3 times 0.25, 0.75? Negative 2. Or, can? Can? So, who is done with 3? Who has not done 3.2 yet? Okay, there we go. Okay, slowly. Can now. Okay. I understand. Is higher than the polynomial. Like you can see here, like the degree, as long as I differentiate it more than 5 times, I'll get 0. That's I. So like in this case, these are example. N is like 5. M, McDonald is 6. So you can see if it's of power 5, right, and I differentiate it more than 5 times, I'm guaranteed I get 0. But it works only for polynomial. If the powers are positive integer, okay, then it works. Okay. Slowly, 3.3 is like a, so if you didn't do right, for example, let's say you never do 3.3, you can do it anytime. You can go back home, read, and then you can do it. It's very, very easy. Also not to worry. Yeah? I'll get to that. Ah. It's just like having a second pedal. Right now. You have two pedals is better than one. Alex, don't show Xing Yu what you did. Okay, faster. Those who are fast, can you do your practice set first? No. Google Classroom has. Yeah, Google. Can send you. Those who want topic 6 practice set. Who's gonna what? Yeah, how are you?
Oh, so
Okay.
I can solve now, but then I just have a question. Well, in this case, right, how do you know which one is divided by which one? So,
Okay,
in this
so
case,
I help you. Okay, so this is what I think. Okay, so you know you are finding this one, right?
Yeah.
Okay, DHDT, right?
Yeah.
Okay, so what I do, okay, I know that here must have derivative DH.
Correct.
Then here I know the last one must be.
Correct.
But we don't usually have DH, H in terms of V. We have V in terms of H, so I will swap it.
Okay.
Can all. So for example, like B and R, right? Is it easier to have dV dr, or is it easier to have dr? Because if I want to, let's say for example, volume, right? Volume can be 4 over 3 pi r cube. This one can help you to find dV dr, right?
Correct.
Or you can say that R is 3 over 4 pi V.
Okay.
Wow, isn't that disgusting? Yeah.
Oh.
So you want to do dr dV, man? I also don't want one, right?
Yeah.
So that's why I'll do. So
Okay.
here, usually volume, area, they are the biggest. I will put them at the numerator.
Oh.
Okay.
So in this case, you want DH over DV lah.
I'll put dV over dV.
Okay. DH.
Because volume is in terms of height. Because what is given to me is 1/3 x square height. Okay. Huh? So-called you think of them as fraction, then the operation makes it's very smooth. It flows like, but they are not actually fractions. Even though a lot of their operations, a lot of their derivatives, they work like fractions, but they are not. They are actually derivative. They are actually rate of change. They are actually gradient. Okay. Okay. So okay. Shall I start on part 4? Or not yet? Who says I can start on part 4? Who says not yet? Not yet. Okay. Hurry. Those who are done, can you start on practice set first?
No, wait.
Stars. Have you ever seen your sky at night outside your house? Are there any stars? Are there any stars? Why are there no stars? Because all the stars are right here looking at me. Okay, Ashini felt disgusted. I saw lower. Okay. 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 Very good. Maria, anyone still doing? All finished? Okay. Okay. One is still okay. So let me see for. Okay, I will slowly soft launch first. I will teach it a second time. Soft launch. Right? Soft launch. SOFTLANU. Okay. So basically, stationary points are points where your gradient is zero. Okay, they are basically turning points or points of inflection. Okay, now if you would like, you may help me to copy this down. This is at the start of part 4. Okay, if you would like, can I ask you to copy this down? If you would like, can you help me to copy this down? Or have copied? Copy already? If you ask you to copy this down. If you help me to copy this down. In a execute. Can you help? Yeah. Explain slowly what's the first or second derivative test. Okay, but you must give me time. You must give me time. Can I? Give me time. You must be patient. Okay, and you must listen. So because it's not easy, not easy. Conceptually need to think. Okay, once I see your pen stop moving, maybe slowly, don't worry. Recorded. I will teach again next Monday. Every topic I will teach a few times so that you all can slowly catch up. If you cannot use catch up, use chili sauce. Topic 6, part 3, generally quite easy. Even if you never do now, you want to skip, go to part 4, that's fine as well. In the past, actually, we combine into one part. Okay, now I'm going to slowly go. Okay. Okay. Hey, Salihan. I never see you wear spectacles before. Huh? You just wear recently. You just try them on. If you need glasses, it's better to wear. I think I was told last time. Okay, so a stationary point 0. Basically, this right, we call this a what kind of point? Maximum point. So actually, this is a maximum point, and this is a minimum point. Okay, so I think you know, very intuitive. I'm not telling you anything new. If you look at a maximum point, you will find that the gradient changes from positive to negative. Just take a look. Take a look. Look at this. So beautiful. You can see, okay, over here, if you look at the tangent, right? Positive or negative? Is the gradient of the tangent plus or minus? Here, 0. Here, minus. So you can see the gradient changes from positive to negative. Okay, that's what they mean by the question. But if you look at a minimum point, look at the gradient here, gradient negative. Look at the minimum gradient 0, gradient here positive. The gradient changes from negative to positive. That's the characteristics. And that's basically the fundamentals and understanding behind the first derivative test. Okay. Now, what is the point of inflection? It's basically like a pit stop when you're climbing the mountain. It either looks something like that. Okay, or like this. Okay, in our syllabus, we will only learn stationary point. We will not learn non-stationary point of inflection. Okay, so there are stationary point. Okay, so okay, all good. So far so good. Yes, no. Can I? Okay, A is a maximum point, B is a minimum, C is a inflection. Basically, for C, you can see that the gradient doesn't change. Okay, so guys, I just ask you very quickly. Now, if I look at the graph, okay, I just give you a line. Okay, okay, let's say I give you this point. Okay, Sean, let's say you help me out. I want to find the gradient here. Can you tell me? This is okay. What kind of point is this? Minimum or maximum? Minimum point, a minimum point. Guys, stay with me, please. Don't do your notes. Stay with me. Minimum point. Can you give me an example of a gradient here? At this point? Good. Negative 10. Very good. Okay, so here, what about this point? Sean? At this point? Okay, negative 8. Very good, Ashini. Over here? Over here? Negative 7. Okay, very good. Over here? Negative 6. Okay, negative here? Negative 3. Very good. Over here? 0. Over here? 3. Over here? 6. Okay, over here? 7. Here? 9. Over here? 10. Look at the gradient as I go from left to right. Okay, now look at the gradient, right? Okay, so the gradient represents what kind of derivative? Right? Right, if I will divide x versus the x. Can you see? Now I go from here. Look, negative 10, negative 7, negative 6, negative 3, negative 1, 0, 1, 3, 6. Now you look at this. This is divide x versus x, right? You know, this part. Correct. The gradient is y x squared. Is it positive or negative? Positive. So what's my conclusion? Whenever is a minimum point, how do I check second derivative test? I start in. If my second derivative is positive, it is a that's the idea of second derivative. Okay, but there will be times where second derivative will screw up. You mess up. Okay, so first derivative is actually the best. Okay, and I will stop here. Please do your assignment and practice set 1 and 2 next week. Thank you, class. Okay, thank you, class.